Okay, so this is a re-recording of the solution on, this is exam 3 of spring 2017 and problem 5 to 9. Okay, this is electrochemistry problem. My previous version has no sound, so this one is a one that I want to record it again so that you guys have a sound. Okay, so let's get on to this and then I'll post it on the YouTube. So the nickel cadmium batteries and what's happening, right? And it's an anode. So remember the on-ox and the red cat. That's something that. So anode means an oxidation. Okay, which one does get oxidized? And that's something that we need to find out. So that we want to look at the nickel. So nickel 2 plus get reduced to nickel, and if you look at the standard reduction potential, that's a minus 0.23 volts, and whereas the cadmium CD 2 plus got 2 electrons, you got cadmium, and that's the minus 0.40 volts. And then like I said in the crash course and in many one, and when we say about reduction potential, and this one wins. So what that means is this will win. So the reduction will happen this way, and the one in the bottom is a lose. So this is an oxidation reaction happening the reverse way. And so anode means an oxidation. So this is happening in the anode. And the oxidation with the cadmium is essentially cadmium 2 plus and the 2 electron, and oxidation happening in the anode. So C is the correct answer. The number 6 of spring 2017 problem shows that you have a copper electrode and coming to copper 2 plus, and this is a more dilute solution, and this is the same copper, but it's a higher concentration. It is essentially reduced into the copper metal. So this is essentially the oxidation this way. This is essentially the reduction this way. And if I draw this, essentially you have 2 beakers, and one is both are copper metals, and then we can understand that that's a reaction that should happen, and you kind of immerse this one. On one side is 0.0032 molar copper 2 plus, and the other one is 4.48, which is more concentrated copper 2 plus. And so if you think about logically, what's going to happen is this is a higher concentration of copper 2 plus, so they want to push themselves to be deposited into this scenario. What that means is for the deposition, you need an electron. So where the electron is coming from is from here, the other side. So this is where coppers are dissolved into the copper 2 plus, so that the concentration gain can go up, and then at the consequences, the electrons are escaping from here. So this is an oxidation. You call this is an anode. So that's all the electrochemistry term that they put it in here. And the electron flow through this direction and meet with a copper 2 plus and higher concentration, and the metal copper is deposited onto this. So therefore, if you write this equation here, this is a copper 2 plus 0.0032 molar is actually being oxidized from the metal. So what I need to do is I need to move this one to the other side, and then say, okay, so copper metal is oxidized into copper and the 2 electrons. And then copper 2 plus, and then which is a 4.48 molar, is going to get reduced to form the copper metal. So it's just that there are same metal with a different concentration, and the electrons are going away. So this one, actually writing the half equation, we have a very important information saying that N here is 2. So that's a very important information. And then the net reaction that defines 4.48 molar becomes and copper 2 plus 0032 molar. So therefore, the Q shown up here is essentially 4.48 molar, 0.0032 molar. So that's the molar concentration between the lower concentration divided by higher concentration, because that's how the reaction, spontaneous reaction should occur, right? So this is how the spontaneous reaction should occur. And also, if I use this color, there is an electrochemical potential. This is a E oxidation. This is a E reduction. And this is an opposite sign for both of them. So E cell for Nernst equation is actually 0 because they are the same types of reaction. So let's write the Nernst equation now for number 6. So we have a space up here. Nernst equation for the electrochemical cell. E cell naught minus RTNF natural log Q. And like we said, this is a 0 minus 8.314 and the 25 degrees C, 298 Kelvin. And N is 2 here, right? So it's a 2. And then Faraday constant, 96500 coulomb per moles of electron. And Ln, Q is 0.0032 and 4.48 molar. Okay, if you tally up, you will get the answers. That is 0.093 volts. Okay, so that's the answer is going to be shown up here. Okay, so that's number 6. So solving the number 3, which of the following species will be reduced first, right? So who will compete? And then so essentially the one, I guess you look for these values, which is what is called the reduction half cell potential, and the one in the higher value, in the rank, they are the one who's going to win. So to begin with, this can receive an electron because they can be reduced. This is already have more electrons, so these are, to me, this is out. And then I'm going to look for the reduction potential for this one. Zinc is minus 0.76. Iron is minus 0.036. And then magnesium is minus 2.37. So which one is at the top? This one, right? So this is a Fe3 plus, getting 3 electrons, getting reduced into this, and that's the one that getting the highest value. So the way that you can find out is you need to look at your reference sheet that is provided for the exam. And also, you guys can find it for yourself from the internet that you can find out. But make these numbers handy for you, and then you can find these answers. So this one is 0.036. Yeah. So I see that that's the one. The reduction. This is essentially, in my term, this is a winner, right? So that's the one. So they will be reduced first because the other one is a dominant player. Okay, so now the solution is a aqueous solution, which is means you have waters, and then there's a copper sulfate, CuSO4, and you apply the electric potential. So electrolyzed, and the gas is observed in a form of an anode. Once again, what we say about anode, right? Anode, ox, right? An ox. Remember, if you actually check your the Google Doc, actually I put up pictures of red cat and then an ox, so that you can have a nice reminder on this. So that means at the anode side there is an oxidation should occurs, and oxidation produces an oxygens. Okay, and in the vice versa, if you think about because they say the gas is bubbling out, so that's a gas, right? For the other side is the reduction happens when there is a hydrogen gas is bubbling out, right? So that's the one. So in this case is applying the electric field is an anode, oxidation gas is being bubbled out. So D is the answer. Okay, so now how many grams, this is an electroplating, how many grams of nickel, and the nickel has the mass for a mole, and we'll be electroplating by passing a constant current of 7.20 amperes. So the unit of ampere is just nothing but coulomb per second, right? The current is, and the coulomb, the charges and current relationship is just how fast the charge is flowing is an ampere. And say through the solution of nickel sulfate. So nickel sulfate produce nickel 2 plus, SO4 2 minus, right? So you can see that now. What you need to see here is nickel 2 plus need 2 electrons to be nickel metal. So that's how the shiny nickel plating that you are going to see. And then we can kind of setting up the unit conversion from this relationship here. So starting from the grams of nickel that you want to know, but what I know is I was given this 7.20 amperes and then the time. So this itself is a Q, which is in the unit of the coulombs, okay? And the time is, let's see, how many grams of constant current through a solution for 90 minutes. Now, actually, this problem is actually they give it to you, the unit of the 90 minutes. So, as you know, this is a second, so all you need is 90 minutes multiply 60. There will be a time for the second, right? So therefore, you are able to calculate the charges in the unit of coulombs of electrons, that is how much is there. And the Faraday constant comes in handy. We know the 1 mole of electron is 96500 coulombs. So by doing so, the previous unit of coulomb can be canceled out. You're left with a mole for liter, moles of electrons there. Okay, and then you need to make transition from I want mole of nickel. That's from here, not from the electron, but this comes in handy that you can get rid of it. And the relationship constant is where you can find 1 moles of nickel, 2 moles of electron. So 2 moles of electron, 1 mole of nickel will be there. So therefore, now your attention is shifted now to the moles of nickel, and then you're going to write moles of nickel, grams of nickel, right? So that you can cancel this one out. That's a conversion. So 1 moles of nickel, how many grams? Stays right there, 58.69, right? And if you kind of add it up, and then you will get the final equation that the number you punch down is 9060. That's a coulomb. Now 96500 using divide by Faraday constant. Now you have a moles of electrons. From moles of electron, you change it into the moles of nickel. From the moles of nickel, you change it to grams of nickel. 69, right? And that will lead you to the answer of 11.8 grams of nickel. Okay, so the answer here is a C. Okay, sorry about missing the sound before. If it caused a frustration, I apologize. Record it again, then you will see the answer version with the sound. Thank you very much for watching this video.